Happy Baby Friday! It is the OscopeWizard Show! Welcome to the OscopeWizard. Thank you for joining me in the techno lair on this Baby Friday. Hopefully it will be a great Baby Friday. I know at the very least it will be the soft close to another week, and we can figure out what we're going to do from there. Yesterday something pretty cool happened here at the house. But actually, before I get to that, we have been facing some very serious theft problems here. At our house, we are growing tomatoes, as are many people, and for some reason, the squirrel population likes to let the tomato get right to the point of ripeness, right at the cusp. At which point, you can see this squirrel has yanked the tomato down. This tomato was far too big for this squirrel to eat. When I chased the squirrel off, it couldn't even carry the tomato with it. It was struggling to bring the tomato with it. And when you go and look at the tomato, all they eat is like a tiny section of the tomato. It's very frustrating. So I feel a little bit like Farmer McGregor out there hollering at squirrels, trying to run these things off. It is so frustrating. In fact, I took a jog. I came back. The squirrel is still attempting to lift this tomato. Clearly, squirrel. It's not going to work. Stop stealing my tomatoes, squirrels. If you see the show and you know a squirrel, tell the squirrel community, stop stealing my tomatoes. Another cool thing, actually a cool thing, that wasn't a cool thing, that's a uncool thing that happened. A cool thing that happened was I got a Father's Day present. I got a basketball goal installed on the side of the house. This is like a pro style goal. You can see it's got a really fancy connection. It's got a crank that I can raise and lower the goal with on to make it so that even I can dunk. I'm still trying to get to that 10-foot level. It is awesome. The backboard is solid. I love it. It has a sweet swish on the rare occasions when I actually do throw the round orange ball through the net and hoop. But, as in all things in life, there was a downside. And the downside became very apparent as I was shooting on the basket for the first time. Inside of the house, while I was playing basketball, unfortunately, it sounded a little bit more depth chargy than we would like. No, in a normal day at my house, there is not any depth charge like sounds. I do not live by a coal mine. I do not live by any heavy submarine warfare. But for some reason, this goal sounds depth chargy. It sounds sort of like we found the Red October style depth charge, which is really not what we're going for when we're shooting baskets. So I do love the basketball goal, but there is some investigation to do to try to minimize depth charge level sounds when I miss the basket. I noticed in the chat, you guys need a tutorial on how to speak to squirrel. I am almost positive if you Google how to speak to a squirrel, there will be at least 4 Wikipedia articles on it and probably 800 different YouTube tutorials on how to speak to a squirrel. All I really need to know is, squirrel, stop eating my tomatoes. That's all I need to know, and hopefully that'll get the point across. So I'm going to start my timer because I'm going to dive into it. I'm going to dive into where we were last time. I got my fancy hat on, my Baby Friday hat, courtesy of one of the junior OscopeWizards, and we're gonna do some measurements. Oh man, A suggestion, put an accelerometer on the wall for when I shoot baskets. It's not a bad suggestion. That is probably a very good suggestion for a future episode. This episode, we are going to continue exploring our Sonos style, our DIY Sonos style amp. We are going to finally retune the amp for our Raspberry Pi Zero. Let's show that so that we can all get on the same page. We're going to retune our amp for our Raspberry Pi Zero. I noticed in the last episode that the levels that we had tuned before were based on just my iPhone analog output, and the digital to analog converter chip that we have chosen to use, which is the PCM5102A, does not have the same analog levels that my iPhone had. So we need to do some tuning. And I have the whole thing set up over here. If you can come with me over to the desk, I have the Raspberry Pi Zero. I have the DAC chip, so this is the PCM DAC chip. I have a breadboard. I think we had a little bit of discussion on a breadboard in a previous episode. If you rewind maybe 10 episodes, you can catch that. But I have a breadboard here that allows me to plug my analog output from my DAC into my analog input on my amplifier. And I also have given myself some probe points here in the middle. So I'm actually probing the analog output from my DAC as it goes into the input of my amplifier. Also, I have my differential channels hooked up, my differential probe hooked up to these cement resistors on my amplifier so that I can measure the voltage output to what will ultimately be a speaker, but right now it's just a power resistor, and compare that to the input voltage. And we're going to use these tiny potentiometers right here. You see there's a couple of you might be able to not see because I have my hand in the way, but I'm pointing at it with my screwdriver. Potentiometers right here that allow me to tune the level of my output so that it is not overdriven. Overdriven, not awesome for an audio amplifier that is trying to reproduce sound. If I go over to my scope screen, this is where we left off. So I have brought it back to where we left off. I'm not going to hit preset because I got it all set up beforehand, and I did hit preset before the show, so you'll have to trust me on that. And I do know the provenance of this setup because I just did it about 10 minutes ago. But this is an example of the output from the DAC chip to the amplifier input, running at max volume. And I was using an AirPlay connection from my iPhone to the Raspberry Pi. So this is the max analog output voltage level with that set up using my iPhone as the source. So one of the things that we noticed in the last episode is there's this weird notch that happens every so often when I get up above 16 kilohertz. So specifically 16 kilohertz and above, I start getting this notch in the output, and I'm just not sure what is causing that. I had some theories. It looks very digital because it's very, very square. I think it must be tied to a digital bus somewhere along the way. If it was analog, I would expect it to have smoother edges. That would be more of an indicator of just regular old analog noise. So here is the digital bus of the I2. So the digital I2S bus, I captured that along with my analog output to see if I zoomed in around here, could I find any weirdness. I should probably have put these on the same grid. Oh, well, I've messed all that up. Let's put these on the same grid. First of all, let's delete my zoom. Let's minimize this. Let's put everything on the same grid. Let's get D0, D1 out of the way. And now, when I zoom, everything should zoom in together. And I'm just curious if there's anything on these digital lines. Nothing on the digital lines really seems to line up. At least on these digital lines, seems to line up with this small gap. So then my thought process led me back. Of course, it led me back to the datasheet. Because if we've learned anything, it's very important to explore these datasheets a little bit. So I scoured the datasheet to see if there was anything in the datasheet that would kind of give me a clue to what was happening. And I did not find any clues in the datasheet, maybe because I didn't read the right words, or maybe because there isn't a clue in the datasheet. But what I did notice in the datasheet was this. The output of this DAC chip should be 2.1 volts RMS at maximum output level. That is the maximum voltage level it is capable of, 2.1 volts RMS. And then that got me thinking a little bit more. So I kept, you know, when you go down a trail, it's worth exploring the entire trail. So if I go back here, I'm going to minimize my digital channels because I couldn't find anything that indicated what was the problem. I noticed that this signal doesn't appear to be 2.1 volts RMS. So if I do an RMS level on channel 1, I mean, it's 800 millivolts. That's a long way from 2.1 volts. So what's the deal? What's going on? Is there some kind of a artificial limit on my iPhone's AirPlay volume level? And there was a way for me to test that. So if I crank my scope up and just start running and capturing. So I'm going to just start capturing the signal. Nothing is going to my Raspberry Pi right now, but I am going to send audio from my computer over to my little amplifier, and I have a tone generator that I found online at onlinetonegenerator.com of all places. I can play a tone. Let's see if I can hit play here. If I just play, let's start from the basics. This is what I always have to do when I'm debugging a problem, is I have to start from the basics. So I'll hit play here. So now I've got sound going. And if I go over to my scope, sound is indeed going. This is promising. So if I hit pause, and now I want to say AirPlay. Okay, now it's attempting to AirPlay. AirPlay is active, that's a good sign. Now if I hit play here, and whoop, let's get that out of the way. See if I wonder if I have the volume super low. Let's turn the volume way up. Oh my gosh, guys. Volume problem, volume problem. Hey, that's why you have to begin at the beginning. What I do notice, though, right away is when I crank the volume up, my RMS voltage is much higher. And I have actually seen it as high as 2 volts. So it makes me think that there was a comment that said the tone generator looks like it was made with GeoCities. I don't know if anybody besides us nerds remember GeoCities, but it totally does. It looks like a website from the long gone, bygone era of of website design. It is humorously antiquated, but working perfectly. So I mean, I won't knock it too hard. I won't knock it too hard. Here we are. So it is working. I have the tone generator going. You'll see that the voltage level, it was 800 millivolts. Now it's up to 950 volts RMS. And I'm just curious to see, it feels like I need to tune this thing as high as possible. So I'm going to crank, make sure I have all the volume cranked up here. Here we go. There is one other tone generator I want to try. right here. So I want to try this tone generator. Let's play. There we go. Look at this. So this one goes even higher. This is something that is super weird to me. So the last tone generator didn't go this high. Look, this is the full RMS voltage level. So what's the deal? What is going on with my voltage levels? How does one tune an amplifier if the sources are going to have such wildly varying levels? In a full amplifier design, one might have a feedback circuit that tries to have a preamplifier, or does have a preamplifier that takes the signal and always scales it to the max. So it takes the input signal and it would always scale whatever the input signal is to the maximum allowable output signal. So whatever the amplifier board, my actual amplifier board could handle, the preamplifier would scale it up to the maximum of that input level. Man, dark mode. Oh man, so there's a lot of complaints over that tone generator website. You know what? We'll hide that and we'll just go straight back to the scope. But it brings up a good point. So I'm going to tune my outputs using this level because this is a high level, and I just want to make sure that I tune it for worst case possibilities until, you know, maybe if there's a good preamplifier chip that I should explore, I don't know, maybe. That might be overthinking something that's going to go in the garage. But let's turn on, here we go, Now we got my output voltage going. Let's scale it so it fits on the screen. Okay, here we go. We have the output of my amplifier over here on the blue signal, which is channel 4. I should probably zoom in a little bit. So I'm capturing a ton of time, and I don't really need that much time. I'm much more curious to see the purity of these waveforms. So I can see that sending in a sine wave is 16 kilohertz. I think it's a 16 kilohertz. I say that. We should probably, you know what we should do? We should probably go in here. Let's go to measure, wake up. There we go. Measure group. For some reason, my internet is super struggle today. Oh, you know what? Also, there was a comment in the chat that said, "Orange enhances everything. The power of orange enhances the signal." Orange is actually my favorite color, so that's a weird aside. I thought I hit measure group. Did I not hit measure group? There we go. Now we're doing it. I would like to add a measurement. Let's add a frequency measurement. All right. Frequency measurement added. And frequency measurement subtracted. Woo. I don't know. It feels like somebody's doing some cryptocurrency mining on my network today. The waveforms are a little bit hard to see, and there was a request to make them brighter. So yeah, sure. Let's make them brighter. There we go. Crank the intensity all the way up. So now we can see these things. So I have a 440 hertz signal, thumbs up, which is what I selected. But we are overdriving the output. So let's, if I go over to my setup here, you can see I'm going to adjust the potentiometer. I think I can actually say I can. Let's see if I can select this. There we go. I'm going to drag this out a little bit so you can see as I adjust the potentiometer, the output waveform will change. Let's pick the right one. There we go. Look at that. The output waveform. So this is actually, so I have adjusted it to minimal gain. So I've turned it off. We do need it a little higher than that. Ooh, this is a trippy little adjustment, isn't it? There we go. That's pretty good. Pretty good. Pretty good. Oh, kind of got past. You can see once you go past plus or minus 15 volts, it clips, which makes sense based on the power level. That might be about as good as I can tune that one. The question I have is, should I tune it for this level, or should I tune it for the level coming from my iPhone? This is a fundamental question, because I'm actually going to be playing the music mostly, if not exclusively, from my iPhone. So it might behoove me to tune for my AirPlay from my iPhone, because that's what I'm going to be using it with more often. And I need one of those blue mini turn pots to make it easier. That is so true. The pots that I have are just the cheap. I mean, this entire board cost $7, $8, $7 maybe. The amount of money that was spent on the components had to be fractions of pennies. But it is working. I mean, it is working. I'm just wondering. I also noticed that as I do this, I'm measuring the voltage level of my power supply, and you'll see as I'm sending a signal in. Let's go. Let's get my camera rolling here. There we go. The voltage level dropped down to 19 volts. It started at 24 volts. Let's see, if I pause my signal generator, stop. So no signals coming. You'll see it jumps up to 24 volts. If I play, huge voltage droop. Huge voltage droop. I'm losing 5 volts when it's actually playing, which is kind of crazy. That's kind of a crazy level of voltage to lose. These are all things that are leading me to believe that an $8 amplifier is giving you what you pay for. The question is, how thin are the supply lines if I'm losing that much voltage? I mean, the supply lines aren't that thin. They might be oh my gosh.
5 minutes remaining.
I don't know. I have this thing set on AirPlay. I don't know if it played or not. I hope it did. But the supply lines themselves here are actually, they're not that thin. I think they're like 15 gauge. No, maybe they're, I don't know. Maybe they are kind of thin. They're not that thin though. I mean, I would expect, if I was using one strand of copper to have that kind of loss. The supply lines are pretty beefy. Well, they're, I guess, relatively beefy, but it doesn't really justify the amount of voltage loss that I'm getting. It has got to be something with that amplifier circuit that is really sucking the current away. I'm going to stop, and I just want to do a real quick test again. So I'm going to turn off my output. I noticed that I have the scope on normal. So when you have it on normal, a lot of times it has trouble triggering when there's nothing there. So I'm going to turn this thing from normal over to auto. So it just updates all the time here. And let me delete these for a second. So I'm going to take my phone and I'm going to send just some music over to the amplifier board at maximum volume as an experiment to see. Oh my goodness. Well, that probably is going to give me a copyright notice for a brief second of sound. Okay, so now some music should be playing over there. Let's turn this way up. So now I have this at maximum volume. You can see that it is much lower. The actual maximum volume is much lower. I mean, let's see if I can get something loud here. Here we go. This is a pretty loud song. It never really gets, I mean, the voltage level is just so much lower coming from the AirPlay on the iPhone. It just feels like I should tune to that, to me, is what I am kind of leaning towards. So I'm gonna do that real quickly so you can see me tune this up. I don't want anything. So I know if I stay within this limit, so plus or minus 15 volts, it is super happy. In fact, what I can do is just draw some limit lines. Let's add a new segment down here. So we'll get some limit lines. These are pretty handy when you're doing testing because it will let you see really quickly whether anything crosses that line. So I'm going to drag them down to plus or minus 15 volts and see, boom, I started getting some clipping there, which is not what I want. So I'm going to turn it down a little bit. Here we are, we're doing real testing. I mean, this is actual engineering, which is kind of cool. So let's do the other side really quickly, and then, you know what, we'll call it a day for today, because we got these things tuned. I've explored tuning them to different levels. I feel like, though, tuning them to the iPhone is really that's the answer, because that's the source I'm going to use. So why would I tune to something that I'm not going to use? So you can see that this speaker was tuned a little bit hotter. So we're pushing up into places where it's going to clip. So let's tune it down a little bit, or turn it down a little bit. All right, we'll turn that down just a hair, a very tiny hair. How are we doing? Still getting some failures. There we go. There we go. That's it. I feel pretty good about that. What do y'all think? What do y'all think? We got the output tuned. We're going to stick with tuning it for the iPhone's AirPlay output because that's how I'm going to actually use the device. So I want to tune it for how I'm going to use it. And if you want to use this amplifier differently, and it's a TPA3116D2 amplifier chip, if you just Google that, or if you go to eBay and search for that, you'll find a ton of listings with this particular chip. If you want to tune it differently, you know what? You can use an oscilloscope and a signal generator, just like I have done. Your signal generator can actually be your sound device. My signal generator is that little DAC chip, so I've tuned it for my situation, and you should, as you are doing your project, tune it for your specific application. Let's see. Yeah. Did I miss anything in the chat? I mean, other than the fact that I have a really bad taste in websites for signal generators. We definitely learned that. I have terrible taste in that. I really appreciate you guys hanging out with me on this Baby Friday. I still don't know all the nerds in the world, and I would love to meet them. So please share this with a nerd in your life, and I'm going to hang out, chat with you guys, and I will see you, hopefully, next week. Bye!